Welcome you to my lecture today. And of course, I want to welcome you back from Thanksgiving break. I hope you're enjoying your Thanksgiving. Actually, before I start today, I'm going to make announcement. I'm going to make announcement because I realize that some students don't normally check updates on Canvas, and that is why I'm gonna make this announcement. The midterm 2 grade has already been completed. If you have not received your grade, or maybe probably you may be among those, because I sent message to some students about the file they submitted, as the file is not accessible, or you probably wrote your exam at the DRC, because I just received a notification that the exam from the DRC, the documents just arrived my office and they're going to be graded today. Okay, so I also want to tell everyone that I added 3 points, extra point across board, and I need to tell you the reason why I did that. I did that because I know we're in the middle of pandemic, and anywhere in the world at this time, the condition under which students learn is not perfect. I actually know that. So that's why I'm using that as my stimulus point or stimulus package. And I also want to say, for those who have earned extra credit in the past and probably you've not used it, if you want to use it towards the midterm 2, I need you to send a message to me, and I'm actually going to apply that accordingly. But you know what? You may decide if you don't want to use it, you can save it for final. Okay, you can actually save it for final exam. And I also, okay, go ahead. Yeah, if I hear you clearly, you were talking about whether you could spend it on or the point on the final or on the midterm. Is that what you mean? Yeah, it's going to be a matter of choice. Like, um, if you want to spend it on the midterm, you can spend it on the midterm. If you want to spend it on final, you can actually save that. But do you know that you can also split? What do I mean by splitting? If you have 5 points, and probably you may tell me, okay, I want to use 2 points. Maybe you tell me add 2 points out of my 5 points to the midterm or to the assignment and add 3 points to the final. You can also split. You get what I mean? Because you earn the extra credit is yours. Have I answered your question, right? Okay. Now, I also want to tell you I uploaded the study guide for the final, the area the final exam is going to come from. Okay. I wanted to take note of that. And I'm also going to review the final practice question with you. Not only that, I'm also going to review the midterm 1, the midterm 2, and the final, okay, before the final exam, okay? And I also want to say this morning, the final exam is going to be an open book. You don't need to worry about sheet, but it's just going to be an open book. You're going to have access to your book. But the only thing you are not going to do on that final, you are not going to search anything online. And I will advise that you come to the class with your laptop, because you're actually going to make use of our software too in the exam. It's going to be a 2 hours exam, and it's going to be written in person at this particular venue. Okay. Okay. Let me see if I have more uh, information to give. Okay, I think I now receive, my email is working perfectly now because I can see student messages and I've been reply to student messages. Okay, I want to welcome you. Oh, before I go to this, you will see that the pattern of the midterm 2 practice is exactly the pattern of the midterm 2, except the multiple choice. I want to confirm to you in the final, there's not going to be any multiple choice. It's just purely going to be essay in the final. I'm going to say that again. There's not going to be multiple choice. There's just going to be purely on essay in the final. Okay, and it's going to be an open book. Okay, the only thing you can't do is to search online. You can do any of that stuff, but you cannot, seek assistance or provide assistance to your colleague. And you're also going to make use of our software in the final. Now, when I review the final practice question with you, I always want you to take my my exam preview very seriously, because the midterm 2, that the question is, as you know, is very similar, directly similar to the midterm 2 practice. I'm also going to make final like that. Okay, I want to welcome you to this topic we call analysis of categorical data. Why is it called analysis of categorical data? Is because the nature of the response is categorical. The nature of the predictor is also categorical. You remember when I was walking you through linear regression, I said we only use linear regression in a situation where we are characterizing relationship between variables in such a way that the response variable is continuous. Okay, but when the response variable is categorical, you make use of logistic regression. But now, what if in a situation where all the variables that I have, they are categorical, then we're going to call that analysis of categorical variable. Okay, now in the analysis of categorical variable, in the outline, we actually walk you through modeling the effect of categorical predictor on categorical response. The response is categorical, the predictor is also categorical. I will quickly give you an example of that. What if you are trying to look at the effect of level of education on the level of income? I'm going to say that again. You are looking at the effect of level of education on the level of income. The level of education is categorical, maybe probably elementary, high school, diploma, college graduate, and so on like that. You know, the level of education, as you know, we have levels. And in the level of income, maybe you probably have those who earn less than $30,000, those who earn, more than that, stuff like that. So that in that situation, you're actually going to have a cross tabulation where you're going to cross tab what I call the levels of one variable against the level of another variable. In a situation where you want to do that, you are actually doing what I call the analysis of categorical variable. Now I'm going to walk you this through example now. Cervical cancer and age at first pregnancy. Now the researchers they want to see whether those who have early pregnancy, maybe they actually have high probability of getting cervical cancer. That is exactly what they want to investigate. And you know what? The data said that we actually want to use come from a case control study, where we actually want to examine the potential relationship between age at first pregnancy and cervical cancer. Of course, if you take a look at the two variables, they are categorical. And of course, in the study, we'll be comparing the proportion of women who had their first pregnancy at or before age of 25. Okay, so which means the age is partitioned into two groups. So it's going to be those who have their first pregnancy less or equal to 25 years of age, and those who have their first pregnancy greater than 25 years of age. You get what I mean? So that is going to be the levels of age. And of course, the nature of the response is going to be whether they have the disease or not. Now, because of that, because the reason why we're trying to do that is because the researcher actually suspected that, an early age at first pregnancy could lead to increased risks of developing the disease. Now, because of that, this example is going to be 2 by 2. Why is it 2 by 2? Because we got 2 levels of predictor and we got 2 levels of the response. Of course, the predictor here, the 2 levels is actually age at less or equal to 25 and age greater than 25. Thus will be the 2 levels of predictor. Okay, the 2 levels of the disease is either they develop the cervical cancer or not. So that is what makes it 2 levels. Now, if you really want to know whether you are actually going to analyze, variable, we're using the analysis of categorical data analysis, where you're going to see a data set in form of this table where you have a cross tabulation. Take a look at that. 49 women actually have cervical cancer, and out of the 49, 42 of them have their pregnancy at the age less or equal to 25, and 7 has the pregnancy at the age greater than 25. So which means out of 366 pregnant women, investigated here, 49 of them actually have the cervical cancer and 317 did not have the disease. And of course 203 out of 317 that did not have the disease actually have their pregnancy at the age less or equal to 25. So take a look at this. This is basically the data set we got from the survey. When you take a look at what I have here, what will come to your mind is probably going to be the test of difference of proportions. I know before now, you might have taken a statistics course before, maybe where you actually test if there's a significant difference between proportions. Which we call the Z test, or and you learn how to construct a confidence interval. But you know what we want to do now? We actually want to go to a special method that we call the method of analysis of categorical variable. Now, let me tell you this. If you want to test if there's a relationship between the age of first pregnancy and the risk of, getting the cervical cancer, we actually need to develop a test statistic, to be able to do that. When I say measure lack of independence, lack of independence means they are related. Look at the word lack of independence, too negative. It means they are related. It means they depend. So because we're going to test an hypothesis, the null hypothesis is going to say there is no relationship or there is no association, and the alternative is going to say there is. Now in the research question, it's actually going to be, is there an association? When I say association, I mean relationship, or I mean linkage. So is there an association between cervical cancer status and whether or not a woman had a first pregnancy out of before the age of 25? That is actually a practical question that we actually want to answer. And in doing that, what we actually need to do, when we say if there is no association, what does that mean? No association means they are independent. That is what no association means. No association means no relationship, and it also means they are independent. And let me tell you this. Mathematically speaking, or probabilistically speaking, how do we actually explain independence of events? If you take a look at this, in statistics, if you take a look at the first one, the probability of A given B, that's a conditional probability, right? Then when it is equal to probability of A, the probability of A is unconditional probability. Now, situation where conditional probability is the same as unconditional probability, then we're going to say A and B are independent. I'm going to say that again. Situation where conditional probability, because the conditional probability here is the probability of A given B. If it is now equal to the probability of A, the probability of A is not conditionally on anything, and that is why we call that unconditional probability. Now, the moment they are equal, then it means A and B are independent. Okay, now what is my A? What is my B? Then I'm going to tell you my A is the age less or equal to 25. Okay, my A, events A, age less or equal to 25. Okay, my B is cancer status. So if the probability of age less or equal to 25 given cancer status is equal to the probability of age less or equal to 25, then I'm going to say there is no association, between, the age and the cancer status. Okay, this is mathematical way, okay, to investigate independence. Okay, so what that means is that knowing something about the disease, because the first one is saying the probability of age less or equal to 25, given cancer status, it means I have information about the cancer status of the pregnant woman. Okay, what is the probability, okay, that age less or equal to 25, if that probability is equal to the probability of age less or equal to 25, then it means there is no connection. It means they are independent. It means there is no relationship between them. And that was why I said knowing something about the disease status tells you nothing about the presence of the risk or factor having their first pregnancy or at the age of 25. Okay, if that happened, then what we now need to do, we need to investigate whether they are independent or not by trying to compute the conditional probability and the unconditional probability that we're going to see whether they are equal. I'm going to say that again. One way to investigate whether the two variables are independent is to four of us compute the conditional probability and the unconditional probability, and the moment they are equal, then the conclusion is going to be they are independent. Now, how are we going to do that? Now, if I want to find the probability of age less or equal to 25, then it's actually going to be how many of the participants have their first pregnancy at the age less or equal to 25. It is 245 out of 366. Therefore, that ratio we give us 0.6694. So it's 0.6694 is actually the unconditional probability. Okay, and the only way to get the unconditional probability is just to find the ratio of the number of the of the participant who have their first pregnancy at the age less or equal to 25 divided by the totality. Okay, and we have that. So which means in the when you multiply that by 100, then it means the 66.94% of the women investigated had their first pregnancy at or before the age of 25. Now, what I computed now is unconditional probability. Now, let us now compute the conditional probability. Now, if I want to compute the conditional probability, okay, I'm going to have two conditional probability. Number one, I need to find what is the probability of age less or equal to 25, given that they have the disease. Number two, what is the probability of age less or equal to 25, given that they do not have the disease? So those are two conditional probability. And how am I going to get the first one? the probability of age less or equal to 25 given cervical cancer, you're actually going to be 42 divided by 47. Don't forget, out of, the 366, 47 women actually have cervical cancer, and out of the 47 women, 42 of them have their first pregnancy at the age less or equal to 25, and that is why it's going to be 42 divided by 47, and we have a 0.8936. Now, if I want to find the probability of age less or equal to 25, given that they do not have the disease, then it's going to be 203 divided by 317. Okay, we have that. Oh my God. All what I'm just going to do now, I'm going to compare the unconditional probability 0.6694 with each of the conditional. And what can you see? They are not the same. Look at that. It's 0.6694 is different from 0.8936 and 0.6404. Because of that, in this situation now, the conditional probability is not the same as unconditional, and situation where they are not the same, then the two events are related. I'm going to say that again. Situation where the conditional probability it's not the same as unconditional probability, as you can see in this case, then our conclusion is going to be the two events are related. It means there's an association between them. Another way to say it is there is lack of independence, because the lack of independence means they depend. Okay, and that is what you can see, and that is why I said these two should be both equal to that for a situation where they are not going to be independent. But let me tell you this. That is what we have investigated now is necessary, but not sufficient. Okay, we came to a conclusion now that the two variables are independent. Okay, I mean, sorry, the two variables depend, they depend. Okay, now we don't know whether our conclusion is statistically significant, because before we can actually, before a conclusion could have a huge effect, is when it is statistically significant. And that is the reason why I said, of course, the observed differences could be due to random variation. Maybe the reason why the two probabilities are not the same could be due to random variation. And what do I mean by random variation? Could be due to chance. And when a difference is due to chance, then that is not a meaningful difference. It means it is not statistically. So what we need to do now, how do we now investigate? How do we now know that the result that we have, the conclusion that we have now is statistically significant? Then what we need to do is to conduct a test. Okay, like I said, the very first investigation was the one that I call a preliminary investigation. That's a mathematical way to investigate independence. There's a difference between mathematical way of investigating independence and a statistical way of investigating that. The mathematical way of investigating independence will only compare the unconditional probability with the conditional probability, but that is not enough. Okay, well, where we want to go now, we actually want to have a way to investigate that statistically. Okay, so if we want to investigate that statistically, what we're actually going to do is this. We're going to assign, we have 4 cells. We're going to assign them A, B, C, D. Okay, we have 4 cells. And of course, R1 is a row total for the first one, right? R2 is a row total for the second, and the C1 is a column total, and C2 is a column total. Okay, now what we are, and N, we're going to use N to denote the sample size. Of course, we used to 366. Okay. Now, the next thing we're actually going to do now is we want to develop the statistical method to be used. And the development of the statistical method to be used will basically based on assumption. I'm going to say that again. The development of statistical method to be used will be based on assumption. Of course, I told you the other time, every statistical model has assumptions. Okay, now we need to first find the probability of risk. What is the probability of risk? The probability of risk is just C1 divided by N, which we call the unconditional probability of the risk presence of the data set. Okay, and after doing that, you know, the probability of the risk is basically the unconditional. Okay, and why am I taking C1? Because the C1 what we're focusing on is the age, you know, of the at first pregnancy at the age of less or equal to 25, and you know the C1 is the totality of the numbers of women that you know that are on that very age, and of course N is the totality of the women. Okay, then the next one is what is the probability of risk given the disease? That is a conditional one, right? The probability of risk given the disease is going to be A divided by R1. That is a conditional one, right? Take a look at that. And we're going to have what we're actually going to do. Under the assumption, we're going to equate the two. When we are equating the two, what are we telling the world? When you are equating the two, we actually want to start from a baseline that says that they are independent. I'm going to say that again. We are you know, that is why when we go into research, we normally focus on the null hypothesis. Because before we go into research, the null hypothesis was true. Okay, and when we get into research, the result that we have is either we're actually going to reject the null hypothesis or we're going to fail to reject it. Now, the assumption we have at the beginning is that the two are going to be the same. The conditional probability will be the same as the unconditional probability indicating independence. That is the assumption we have from day one. Okay, so we're going to equate them. Look at that. We equate that to that. And when we equate that to that, we got A equal to R1C1 divided by N. Oh my God, you know what I'm trying to say now. 42, 7, 203, 114, they are observed values, observed. But what is A, B, C, D? We needed to compute the expected. We have observed values now. We needed, for any given observed value, we need to compute the corresponding expected value. I'm going to say that again. What we have in the cell right now, 42, 7, 203, 114, they are observed values, the values we observed. But A, B, C, D are expected values. We need to compute the expected values. And you know what? If I want to get the expected value A, then I'm going to do what? R1, I'm going to multiply it by C1. So which means if I want to get A now, it's going to be 49 multiplied by 245 divided by 366. And that is the way I'm going to get the expected value for the cell 1. I'm going to do the same for other cell. Okay, for other cells, for B, for C, for D, that is what I'm going to use. So which means if I have 4 observed cells, observed scores, I'm going to also have, I need to compute the expected. And you know how we got the expected, right? We made an assumption from the beginning that the two variables are independent by equating the unconditional probability to the conditional probability. Every statistical model has assumptions. That is assumption we made from the one. Okay, and that will enable us to obtain the expected frequency. Is there anyone, either online or in person, that doesn't understand how to obtain the expected value? Is there anyone that need more clarification? Those of you online, you can still hear me, right? Those of you online, can you confirm? Okay, thank you so much. Thank you for confirming that. Okay, now, the next thing that I'm going to do now, I'm just going to go. Now, why am I computing the expected? Because in the analysis of categorical variable, we don't use f-test, we don't use logistic regression, we don't use ANOVA, but we use a chi-square test. Chi-squared. That is what we use. And you know what? The chi-square measure discrepancy between the observed and the expected. And that was why we were trying to obtain the expected. Now I'm going to show you something now. This is the chi-square that I'm talking about. Can you see something? Chi-squared? And the chi-square is just going to be the sum of the square of the difference between the observed and the expected divided by expected. And that will give us a calculated chi-square value. We use a chi-square to, to carry out, to conduct a test whether two categorical variables are independent or not. Don't forget the other time I showed you the mathematical way to do that, and I said that was not sufficient enough because we don't know whether the result we got was just due to chance. And that is the reason why we're actually going to use a chi-square test to be able to investigate whether the conclusion we had the other time is statistically significant. Okay, and of course, the chi-square comes with the degree of freedom. Okay, the degree of freedom is going to be R minus 1 multiplied by C minus 1. The R is the number of rows, and C is the numbers of columns. Okay, I think I'm also going to say R represents probably the numbers of levels of one variable, and C represents the numbers of levels of another variable. Okay, you subtract them from 1, you multiply. Okay, now, and of course, that is the distribution of the chi-square, is q to the right. Now, let's go back to the data set. Now, to the data set, what I have presently on the data set, they are observed, and we need to compute the expected. And of course, using the formula that I show you, I wanted to look at that cell. That is how to get the expected for each. For cell number 1, when the observed is 42, the expected is 32.80. Cell number 2, when the observed is 7, okay, the expected is 16.20. Cell number 3, when the observed is 203, the expected is 212.20. Cell number 4, when the observed is 114, okay, the expected is 104.80. Now, for you to be able to use chi-squared, you need to have observed and expected. Okay. Now you have your observed, you have your expected. Now, what is the next thing to do? You're going to put them in. You've already put them in now. Take a look at that. You've put them in. Okay. What I'm trying to show you now is a manual way to do that. You can also use our software. You know what you're going to do this week? My TA is going to walk you through how to implement something like this in R. But what I'm just trying to show you now is a manual way to go about that. Now, for every observed, you have expected, right? What are you going to do to them? You're going to go to the chi-square now. Okay? You're going to go to the chi-square now. Observed 42 minus expected 32.8 squared divided by the expected. You do that to all the 4 cells, you add them together, and that becomes your calculated chi-square. Now, at the end of the day, my calculated chi-square is 9.011. That's a calculated chi-square. If that is my calculated chi-square, then I need a degree of freedom. What will be my degree of freedom? You know, the numbers of levels of each category is 2, right? 2 minus 1 multiplied by 2 minus 1, that will give me 1, the degree of freedom. And you know what? We have a code where we're going to check when the chi-square value is 9.011 with the degree of freedom equal to 1 at a particular level of significance, and that will give us the p-value here. Then I want to tell you, my TA is going to walk you through how you can implement that now. Okay, and you know what? When you take a look at the p-value that we have now, it's 0.0027, and that p-value is less than the 0.05 level of significance. When a p-value is less than the 0.05 level of significance, what are you going to do? What you're actually going to do is to reject the null hypothesis. Don't forget, what was the assumption that we made from day one? The assumption we made under the null hypothesis is that the two, variables are independent. There's no association between them. Okay, and the alternative is going to be they depend. Okay, now that the p-value is less than 0.05, then you're going to reject the null hypothesis. Don't forget, the null hypothesis is the assumption you made from day one. The assumption you made by trying to equate the unconditional probability to the conditional probability. That was the assumption we made. Okay. And of course, you can use an online calculator. If you don't want to use our software, all what you just need to do is supply the degree of freedom and the area of the region, 9.011 that you got, and it's actually going to give you the p-value. Okay. If some of you want to use an online calculator, I'm gonna. If you don't have calculator and you want to use online calculator in exam, of course I will allow you. The only thing you can search for any other thing online. Okay. So in the end, well, I think this is just to show you the p-value and what is our decision here. We have strong evidence to suggest that at age of first pregnancy and cervical cancer status are not independent. You know the meaning of not independent? It means they depend. It means there's an association. It means there's a linkage. Okay, so it means they are related. And that you can say the p-value is less than 0.05. And in conclusion, we're going to say in particular, we found that the proportion of women having their first pregnancy at or before the age of 25 was higher among women with cervical cancer than for those without. That is our conclusion. Okay. Other thing we can do here, which I may not necessarily, which I'm going to reserve for further course in statistics, is what we call the odds ratio. You don't really need that, but I just want to tell you, we also talk about odds ratio. Of course, we talk about odds ratio in logistic regression. And here too, we can use the idea of odds ratio to to do the analysis of categorical variable. Why do we say odds ratio? Ratio of two different things, whether you have the disease or not. And you know what? For us to use, the Fisher exact test or the chi-square test that we use, we got to make sure that the expected value is at least 5. Of course, the condition was satisfied. I'm going to show you why, because the expected value, each expected value we got is greater than 5. Okay, that condition is satisfied. Now, the last example for today is response to treatment and histological type of upskin disease. We have 2 variables. The first example we did, each of the variables have 2 levels. But in this example, the levels is not 2, and it is not compulsory that they have to have the same level. Now, the question we want to ask here, we have 4 different types of upskin disease. And We want to see whether the response to treatment depends on the type of disease. I'm going to say that again. We want to conduct an investigation to see whether the response to treatment by patients depend on the type of disease. We have 4 types of disease here, of Hawking disease. Now, we select a random sample of 538 patients diagnosed with some form of Hopkins disease, and we have 4 types of Hopkins disease. And of course, the response has 3 levels. The response, the first one is none, partial, and complete remission. What do we mean by remission? Remission is like a disappearance of symptoms. Okay, that doesn't mean it cannot reoccur. Okay, now the practical question is there an association between the type of Hopkins disease and the response to treatment? If so, what is the nature of the relationship? Now you got a table. This is the table you have. 4 types of disease and 3 types of response, and you want to see the way our patient respond to treatment, whether it depends on the type of disease. Now you're going to do the same that we did before. By 4 of us investigating, you start on a mathematical way where you investigate whether the conditional probability is equal to the unconditional. Look at that. The probability of positive across all disease is 314. Okay, across all disease, which is this guy here, 314 divided by 538. Then what is the conditional now? Okay, we're going to have 4 conditional probability. The probability of positive given a disease ideal, the probability of positive given the other, because there are 4 type of diseases, you're going to have 4 conditional probability. Now, when you compare, they are not the same with the unconditional one. Because of that, you're going to say they are not independent. But this is not enough. Okay, then we're going to use, we're going to use chi-square test to be able to see whether the relationship, is due to chance that we talk about is due to chance or not. So but before we do that, you can 4 of us have a Mosaic plot. What do I mean by Mosaic plot? A descriptive way to look at the response, to the different type of disease. Now, you're going to see, you see LP, 71.2% of the patient responded positively. Look at that, to that LP disease, looking at this Mosaic plot. Okay, that was why I said clearly we see that the LP and NS respond most favorably to treatment with over 70%. Look at them, the one in blue. This will give you opportunity to see if patients have different, maybe they have different diseases, and you want to compare their response to treatment. You want to see whether the response to treatment depends on the type of disease. So that is, you can see here, right? Okay, and you can see that the LD is only 25% of the student, of the patient that responded positive. Look at that. Now, I see this is not enough. You can go by what we did the other time. On each of these, obtain the expected on each cell. There are so many cells. We have 1, 2, 3, or 3 by 4. You're going to have a 12. Then we're going to find the expected cell for each of that. And when you find the expected cell, okay, that is the expected cell for each of that. You have the observed, you get the expected for each of that. Then you are ready to obtain a chi-square, which is going to be this guy here. Observed minus expected, all square divided by the expected, and the calculated chi-square here is 75.89. Then the degree of freedom is going to be 6. Why 6? The levels of the disease is 1, 2, 3, 4. Subtract 1 from 4, that will be 3. Okay. And here, the levels here is 3. 3 minus 1, 2. So 2 times 3 is 6. Okay. When you plug that into the online calculator or using the software, you're going to have a p-value of that. What is the meaning of that? When the p-value, 0.0001, that is less than 0.05, then you're going to reject the non-hypothesis. Rejecting the null hypothesis means response to treatment by patient depends on the nature of the disease. That is what it means. And we've already seen that in the Mosaic Plot. And that was why we said we have strong evidence of an association between the type of opt-in and the response to treatment. Okay? That is the end of the lecture today. Okay, is there anyone who want to ask a question before I go today? Is there anyone? If you find today's topic interesting, can I see your hands up? If you find it so interesting, okay. But you know what? Do not hide your feelings. If you don't really understand, meet with me during my office hour tomorrow. Okay, and if you have seen your result for midterm 1, midterm 2, believe you can still have A in my class. All what you just need to do, be present when we're doing the final review practice. The pattern, the pattern in the final review practice would be the exact pattern in the final exam. I'm assuring you that. Make sure you stay safe and have a good day. Yeah, thank you too. Yeah, somebody asked about what time is the final taking place. We advise the person to actually check the syllabus. The time I put on the syllabus, on the course syllabus, is the exact time the final exam is going to be taking place. So check the syllabus. Thank you. Yeah, how are you?